Welcome back to another one of my sort of vector videos. This will be focused on converting between polar and Cartesian forms or coordinates. And just in case you didn't notice, Cartesian, polar, this will be revolving around 2 dimensions. That's because when I'm doing 3 dimensions, that'll be on spherical and Cartesian. Polar is only 2 dimensions. So, let's get right onto it. So polar is basically when you have a magnitude and a direction, which is your angle. Cartesian, I'm just going to write cart for short, is when you have your x and your y. Okay? So that's sort of like when, let's say you have a graph. I'll do one for this. So that would be, you'd have it pointing in this way, and that'd be your R, and that'd be your angle. And for Cartesian, just draw a line, you would have basically sort of just going to a point of X and Y. Okay, now I'm going to be doing this with vectors though, so this will be X and Y. So that means we'll be focusing, this one will be given the angle and the direction, and we'll be converting to an X and Y. And Cartesian, that's by its own. If you have just the rounded brackets, X and Y, that means you're just talking about a point. When you have these, like I explained in my vector introduction video, that's when you talk about going to that point. So that's saying the point, and this is saying going to the point. Okay? So we won't worry about that now though. So, because I only did this part of a vector video because I'll be pointing in directions and magnitudes and directions, which is vectors, magnitude and direction. Okay? And if you want me to do one on polar to Cartesian on just points and not vectors, then I can do that, but I'll be focusing on vectors for this. Now, when at polar form, when you want to find R, you basically, if you want to find R and you've got the X and the Y component and the X component, and you want to find the magnitude and the direction, well, R equals the square root of X squared plus Y squared, which means if you square root X squared plus Y squared, you will get the value of R, which is this here. And for theta, the formula is tan theta equals y on x. That means theta equals the inverse of tan y on x. Okay? So, you put the inverse of tan, you put the y component over the x component, and you will get the angle. Okay? And for Cartesian, when you want the x, if I wanted this x value from what I had here, I would do r cosine theta, which means x is this one, would be the bottom, and I would use r because cosine is equal to opposite, which is equal to cosine is equal to adjacent over hypotenuse. So all there is they just move the r on this side. So instead of it being x on r equals cosine, they've multiplied both sides by r, and that's what it looks like. So if you want to find the x component, this bit here, you basically r multiplied by cosine of the angle, and that will give you the x component. And if you want to find the y component, this bit here, you just y similar is r sine theta, or the angle, which, because sine is opposite over hypotenuse, if you want to find this bit, it's the magnitude multiplied by sine theta, and that's how you get those. And we'll be using these today. So I'll do an example for each, and I may or may not do a second video. Okay, so example 1 will be for converting from Cartesian to polar. So we're given Rx equals 3 and Ry is equal to 1. Since we're doing vectors, you could do the x component of R and the y component of R, and vectors. If you were doing it with vectors, you'd have to use these squiggly lines. And so that means we've been given something that goes across 3. So the x component of R equals 3. And we've given something 1. So that goes off about there. So the y component of R equals 1. Now what we want to know is we want to know R, what R is, and we want to know the angle. So how do we do that? Well, from the if we just change a bit the equations we got given here, what we have is R. I'm just using a capital R. Before we had a lowercase r, doesn't really matter. Equals the square root of the x component of R squared plus the y component of R squared, which is exactly the same as here. Keep in mind that it's just this is the y, this is the x, and this is the r. See? This is still the y, this is still the x, and this is still the r. These are just the components that make up that, which is what is obvious. Okay? And that there will equal sub in x, which is square root of rx equals 3, so 3 squared, plus ry, which is 1, so that's 1 squared. And we get square root of 9 plus 1 equals the square root of 10. I'm just going to leave it as the square root of 10, because if we do that in our calculators, we'll get a big decimal, and I couldn't be bothered writing that. I'm just going to leave it nice and neat as the square root of 10. So that's our r. So this r value here equals the square root of 10. And now for the angle. So put these to say, therefore, r equals this much. And now we're finding the angle. So like we said before, tan theta equals y on x. In this case, it'll be tan theta equals the y component of r on the x component of r. Okay, so we rearrange this, and we get theta equals inverse of tan, and these. Now I'm going to write the y component, which is 1, over the x component, which is 3. Okay, so we put that in, and we get 18.43 degrees, or that equals 0.3217 radians, depending on what you're trying to answer the question in. Okay, so now we found the angle, which is 18.43 degrees, and or in radians, and we've found the magnitude, which is square root of 10. Okay, which is what we wanted. Now what we're going to do is convert from polar to Cartesian. So example 2, polar to Cartesian. Okay, so r equals, another way you could write it, instead of writing just you could write it in a sense, some people have seen write it in, this is to signify a vector, but I've seen some people write it in this way where they have the magnitude and then they have the direction. I've also seen some people write it as just r equals like the magnitude, and then they do this in the direction, which just, this means essentially the angle is that's talking about the angle inside. That's just another way I've seen it. I'm going to use this way just because it's easy to understand. This is your magnitude, and this sort of signifies the angle, and whatever the angle is there. So hopefully I didn't confuse you too much, but we're basically going to say that the magnitude is 5 and the angle is 135 degrees. So if we draw that, this will be our y, and this will be our x plane. This will be our x plane, this will be our y plane. and it'll be somewhere over here, because that'll be 135 degrees, and this magnitude R, some people write it like that, will equal 5. So yeah, some people write it like that, whatever works for you. Okay, and what we're trying to find is the components. So we're trying to find the x component, or in this case the rx, and the y component, or in this case the ry, which is basically saying the x component of r and the y component of r. Okay, so what do we do to find those? Well, these are the formulas here, and if we change them to suit, this will still be r, but this will be rx, and this will be ry. Okay, so rx, the x component of r, equals r cosine theta. Okay, and so if we sub that in, we get r, which is 5, and then cos or cosine 135. Make sure it's in degrees if you're doing this on your calculator. And what we get? Negative 3.5, which makes sense because this vector, I should be writing them as vectors, but this vector here is 3.5. The magnitude is 3.5, but it's a negative, which means it's going in the negative x direction. Okay, because remember, this is positive x, this is positive y, therefore this is negative y and this is negative x. So it's saying 3.5, yes, it's 3.5, and it's pointing in the negative direction, which is correct. Okay, and for the ry value, the y component of r, we will be focusing on r, do a squiggle, r sine theta. Just like before, 5, which is the magnitude, multiplied by sine of angle, which is 135, which then equals positive 3.5. Just write these off and put a therefore symbol, so it means that this is our final answer. And that makes sense too, because that's positive. It's 3.5 in the positive, which means it's 3.5 going up, or in the positive y direction. Okay? So that's basically it. And this makes sense because 135, if you found the angle here, if you subtracted 90 from that, this angle here, you would get 45 degrees, which means that's 45, that's 45. This should be the same length as this. And that's what we've got. Okay, 3.5 and negative 3.5. Now, there's another way you can do this, and I'll show you if I do a second video on it. But it's more saying that some people, they like to just focus on the angle here. Instead of, they don't worry about that. They use this to find the angle here, and then they use this angle to find the components. And I'll do that if you want in another video. But right now, I'm just using this angle here, because to find the x component, to find the x component, if you just use the magnitude times cosine of the angle, even if it's pointing all the way down here or pointing this way, if you have the angle that goes from this starting positive x all the way to the magnitude, if it's there, or there, if you just do this simple equation, you will always find the x, and if you do this, you will always find the y. Okay? Anyway, on that note, I hope this video helped. Thanks for watching, and hope you have a good day.